is Sam Zuckert. I'm a student at the Harris School of Public Policy. My focus is on education policy specifically, but of course that can be broad, and I'm very excited to learn about technology tonight. Tonight we were lucky to be joined by Anita Nikolich, a research scientist and the Director of Research and Technology Innovation at the University of Illinois, and in addition to holding appointments at the University of Chicago and the Illinois Institute of Technology, so a very busy woman. She's an expert in security, privacy, networking, enterprise, IT operations, and scientific cyber infrastructure, so a very knowledgeable woman as well. And the former cybersecurity program director of the National Science Foundation. So we were very excited to have her here today. And like Bruno said, this is Jonas Heim, a Fulbright scholar, currently pursuing a Master's of Science in Computational Analysis and Public Policy at the University of Chicago. So he'll be doing a little more of the leading of the interview today as his study focus is more in line. And he hails, like you said, from Lucerne, Switzerland. Let's just kick us off.
Thank you so much, Sam. Thank you so much, Bruno. So Anita, let's start very broad and give our guests some background. So what exactly is AI?
Sure, and I should mention I was an instructor for Jonas. We had a class, so I have
true.
I have a lot of tidbits here because AI is never fun unless you have a bunch of really interesting stories. So you can kind of split AI into two versions. One is kind of pre-2000, where it was a set of rules, if-then rules, mostly for things. If you think about Deep Blue doing chess, it was a set of very structured rules for making decisions. Early AI were things like the post office in the late 80s, early 90s would use optical character recognition, which is a set of rules. After 2000, AI has changed where we're trying to integrate more human judgment and more human abilities. And if you hear the term neural networks, that's what that is. So instead of just the if-then rules, we're trying to apply what neurons in the brain do, which is make decisions and kind of judgment that's not just based on if-then rules. And if you think about a comparison, Deep Blue chess was if-then rules. They were doing 200 million per second evaluating moves. Now AlphaGo is the big thing. Go is this ancient Chinese game. It's very, very hard to outwit it. And AI did it a couple of years ago, which is a big deal. So that's that in broad strokes, that's what that is. And a lot of the post kind of 2000 era is because of much cheaper compute and a lot more available hardware and a lot more available data, which I know we're going to talk about.
We are. And so, like, what is the goal of AI usage? Why is it so widespread nowadays?
So, AI is really good at things like pattern matching. So, we're going to talk about data, but you train AI with feeding it a lot of data based on mostly on past performance. And by training it, AI is really good at making predictions. So, probably one of the really great places it's used is for things like fraud detection. So your Visa card or your bank says, we think that there's some fraud. That's because AI has done pattern matching. Spam emails, if you notice, if you've been on email for the past 30 years, the past 5 to 10 years, you're probably getting a lot less spam because it's really good at matching the patterns of spammers, which is replacing certain characters. And things like speech to text. Again, because of a lot of data, when we speak now, it'll be able to put that speech into text. So anything that's really pattern-based, AI is really good at.
Exactly, and so you've already kind of touched on the data side. Why is data such an important aspect of it?
So you need data to be able to do any kind of pattern matching. So the credit card fraud is fairly easy. We know what your purchases have been like for the past month or year or 2 years. But when you get into other things like facial recognition, so if you go to a Taylor Swift concert, you're going to have to go and put your face into a scanner because they are worried about stalkers of Taylor Swift. Well, how do they know that you perhaps are the Taylor Swift stalker? Because they have, one of the companies called Clearview AI, they have 4 billion photos, obviously, different types of people, different situations. They collect those from the internet, they collect them from databases, they train the AI to look for certain characteristics. So data is really important because you can't train that whether it's on faces. Now we're training AI on biometrics. So things like your handprint, things like your gait. There's something called gait analysis where in some countries they will take photos of you going down the street, not just your face, but how are you walking? So everybody has a very distinct gait. So all that data is collected. Some of these data brokers have what they say are about 2,000 points of data on any one person, and I've seen these databases. Facebook, on the other hand, has 50,000 points of data on you. So if you're a Facebook user, 50,000 points, meaning who do you click on, what do you like, 50,000 characteristics. All this data is, and that's just a sliver of the type of data that you need. And that's just talking about kind of social AI, not even the kind of AI used in science.
So the more data you have and the better quality it is, the better for AI algorithms, correct?
Yes, I hesitate because there's all these issues with data. There's principles called FATE, fairness, transparency, ethics. What does it mean to have good data quality? So you can have great data quality of people's faces, but in some respects, people are asking now, is it ethical to collect that data of people's faces? Are you violating privacy if you're using that to train a model? But yes, good quality data you have to make the predictions come out better.
And so you've already touched on some controversial uses of AI, Taylor Swift and face recognition, etc.
Student success.
Student success. Let's. So I want to focus on one to give our guests an example of kind of what goes into those discussions about the ethics of AI and their usage. So one such example that we looked at in class was the use of COMPAS, which was an AI algorithm that's called the Correctional Offender Management Profiling for Alternative Sanctions. Very complicated name, very complicated algorithms because it used 137 variables to essentially determine the likelihood of a defendant in court to become a recidivist, so committing another crime. Can you tell us a little about why was COMPAS used in the first place and what made it so controversial?
So COMPAS it's a proprietary software. It's a software that a lot of jurisdictions will buy, and primarily what drove people to buy it was the justice system. There's a lot of people. There's a long wait time. So what they were hoping, people buying the tool were hoping to do is say, who do we think is going to reoffend so they can set bail? So it was primarily for pretrial hearings. And what COMPAS was supposed to do is assist the judge. So these 137 points, it should point out that it wasn't just 137 points, it was 137 questions that were answered when you were arrested. So things like, do your friends do drugs? Do you stay out late at night? All these things that were supposed to paint this criminal portrait of you. It would then spit out a risk score, somewhere between 1 and 10, and the judge would say, this person looks like they're a 1, so it's okay, I don't have to set bail, I can let them kind of go for a little bit. Versus a 10, we have to be more cautious about them. So at a high level, that's what it was supposed to do.
Was it, so again, it was from the get-go a very controversial topic. And when people did a bit more digging, it turns out that it was maybe biased against certain demographics. What exactly happened there?
So COMPAS predicted about 61% of the time whether people would reoffend. So, essentially not a whole lot better than a coin flip was the accuracy. But what happened is, and if you were to compare all these fancy 137 traits, and the algorithm took these traits, these answers to questions people had, they also took into account age, sex, where you live, zip code, and spit out this risk score. If you were to only look at age, sex, and prior offenses, that was no better than on the 137 traits. It was really just based on a linear regression of those 3 things. But although they said they didn't take race into account, blacks were 2 times more likely to be labeled as riskier of reoffending, as high risk, which didn't actually prove out, but they actually didn't end up reoffending. But they were shown to be twice as likely to potentially reoffend. So what it has, ProPublica did this very large investigation where they show that although the algorithm supposedly didn't take race into account, it very clearly said blacks were riskier of reoffending.
And that's a shocking result.
It's shocking.
And of course, should not happen. But when you look at AI and the different applications, that's a theme that is very recurrent. Is there something you can do in the data, like remove certain variables, like ethnicity, to take away that bias?
Well, I mean, first of all, AI for determining social outcomes is, by and large, I don't want to say doomed to fail, but it is doomed to be riddled with things like this. So there's been other uses where AI is used to predict, in the DCFS and in the child welfare system, is somebody going to be a bad parent? Are they going to get kids taken away? Things like that. And by and large, the results are fairly similar, where when you try to predict a social outcome, you're predicting an outcome based on the data that has trained the model in the past. So if you're predicting if somebody's going to reoffend, that prediction is based on somebody, excuse me, who's been arrested, who's already had an offense. So the first thing is using it for things like social outcomes is not ideal. There have been studies showing that using this kind of AI to predict things like if you get points on your driver's license, insurance companies have found that's a pretty good indicator of who's at risk for a car accident or something like that. But that's not that's an insurance use. That's not a social good type use. So yes, for social outcomes for sure, this is what's hard about the data is if you want to be fair and equitable for certain types of AI usage for faces, you want to make sure to have a broad set of faces that are white and Asian and black and different types of shapes of faces. But for these kind of outcomes for social ones, should you have those characteristics as part of it? It's still a toss-up.
So to conclude the discussion on Compass, do you see a place of AI in criminal justice?
AI has not fared well in criminal justice. So a couple of other examples. So in Chicago in particular, they had this thing called predictive policing. And predictive policing was actually, it started in 2000. It actually started at IIT, where I was faculty, with a person who was not a criminologist or an economist or anything like that. He was an epidemiologist, and he thought that crime was like tracing a disease, the spread of a disease. And if you could find the nexus of where the crime was, you would find the people who committed the crimes, and you could just solve policing. At the same time, Chicago Police Department hired a new chief data officer specific to the police department. And by the way, he was never actually a street cop. He was a data science dude who went into the police to do data sciencey things. But they had this predictive policing where they thought they would have a strategic subjects list. And what this was, and it ended up being thousands of people on this list, where if you were near a crime or in a certain neighborhood, you'd get stopped and you'd get put on a list. And what it's supposed to do is say you have the chance of either getting shot or being a shooter. And there was 11 traits that were part of this predictive policing. And that was supposed to inform police that if I saw you and you're on the subject list and you have a high score, that I should keep an eye on you. This was found, probably from this description, you can tell to have just rampant problems where the city was then sending crime forces to areas where they thought there would be crime, and of course, that really doesn't help. That exacerbates tensions, and it didn't actually find more criminals by doing that. The other place that it was used is something called ShotSpotter, where the police thought that if they had some acoustics and they could find out where gunshots were, that would be a good thing. In theory, not a bad thing for policing and criminal detection. In practice, though, a report came out last year from the Chicago police who stopped using ShotSpotter that, for example, there were some shots fired at Lakeshore Drive, and I think 54th. Someone got arrested because he happened to be there at the time where the shots were. Turns out he had nothing to do with the crime. The police actually kind of tweaked the records to say, well, maybe he was doing something there. That started investigation. So you can see with these stories that, and it's not just Chicago, using AI in the criminal justice system is bound to fail unless it is tempered by human judgment by judges. And some of these judges, as they show them what was under the hood of Compass, said, I get a feeling. The reason for Compass is you don't want to rely on the judge's feeling, but still some of these judges have a spidey sense that, this other person wasn't risky, but I kind of got a bad feeling. So I think, it's like other uses for medical or other type of AI uses. I think as an assistant, it can be useful, but not as the determination for judgments.
Exactly, and that's interesting that you mentioned other areas too, because now we talk about criminal justice. Not everybody might have experience with it, but AI is truly interfering in everybody's lives. From AI-driven applicant assessments. If you apply for a job, it's going to scan your CV, give you a score that you do not necessarily know where it comes from. Credit scores, self-driving cars. AI is everywhere. And so now let's take it a step back from the applications and go back to the development phase. Are the people that develop those algorithms, are they concerned with these ethical questions? Like in Compass, were they thinking about the ethical considerations of that, or are they mostly people that care about the technology and want to push the technology as far forward as possible?
It's interesting. You definitely can't speak for everybody, but it's been a big trend of discussion in the past few years of should computer scientists and data scientists have to take an ethics course. And by and large, you're talking about just the training of these people who are creating the algorithms. And the answer is always, no, we got to have more math, and we got to have more algorithms and engineering, and less ethics and less, fluffy talking type stuff. So it's not that they're not concerned, but there's a big school of thought that AI is just an algorithm and it's just numbers, and numbers don't lie. It's just math. And we know that's just not true. For example, some of the research that comes through, completely shocking that this is peer reviewed, is something like, evaluating the trustworthiness of a person from the shape of their face. Like, in theory, we got rid of this in the 1920s when it was actually used for immigration purposes in 1924. It was when you were immigrating to this country, if your face was a certain shape, you were, from Italy or places that were deemed, we don't want too many people from that place. We're hearkening back to uses that are completely not scientific, but these are funded by science agencies and companies where doing things like your face looks trustworthy, or by typing a certain way, I see you are too emotional and you shouldn't make a decision for the company. And finance companies are doing that, where the AI is saying you perhaps had a bad day and you're too emotional to make a good decision.
Fascinating.
So, yeah. But this sells, right? So the developers are often in a tough spot where it's hard. Many of them see with data collection and decisions that it's not the right thing morally, ethically to do, but it spits out data that is fulfilling what the company, what that is to do. So I do see more and more younger, both developers and people in enterprises, and we've seen this codified into law recently, where they're pushing back to say, if you're going to use AI for hiring somebody, what's that really based on? And I think that's where I'm seeing more generational pushback, where people are thinking a little bit harder before they recommend this to their boss, to their decision maker bosses.
And so, as you've said, those algorithms is what sells. So someone is going to make them. And when someone is going to make something that is not necessarily beneficial to society, usually there are policies and laws that get put into place. What is the current landscape of the policy around those tools? So,
yeah, I'll start with, the U.S., needless to say, is far behind many other places in the world. But I'll start with the U.S. first. So the landscape of that is, this tends to be at a state-by-state and city-by-city level that a lot of this is decided. Illinois has been pretty good about this. Illinois has this Biometric Security Act. So if AI is used in hiring in the state of Illinois, you have to let an applicant know. They have to, you have to get rid of their data if they ask you. But that's been a little bit under the radar. The big one that's come up, and I'll kind of work my way up to the national and then international level, is New York. So New York City, starting in January of next year, if a company or government uses an AI-assisted hiring tool, and it's a very broad definition. It could be scanning resumes. It could be one of these interviews. If they use any kind of tool, they not only have to let the candidate know and give you an opt-out, but they have to get it audited. So this is bringing up a whole other kind of for people who are data scientists to really, and that it's not super prescriptive. What does it mean to audit? It could mean that you need to tell me all the data in it. So that's a little squishy, but that's a really good step forward that the city of New York is saying you have to have an audit, and it has to be done yearly on how the decision's made, on statistics and outcomes for various populations. That was pushed by the Equal Employment Opportunity Commission in the US. So in DC, although they don't regulate cities as a whole, they said, since AI hiring is used so broadly, we need to make sure that we are preventing discrimination, and that's what they're supposed to do. So that's an example of a very city level, then you have state level, things like privacy protections, which are part of the data, that's at a state-by-state level. So the US has no comprehensive privacy or any sort of regulation in this area. What they do have, starting last month, the White House put out this AI Bill of Rights, which is a good start. It's very kind of generic to say if AI is used, it should guarantee you data privacy, it should guarantee non-discrimination. So that's kind of one angle in the US. Where we're really lacking is very specific guidelines technically for developers to say if you're going to make something that's fair and ethical, what does that mean? Do you have to have a huge data set? Do you have to not have a huge carbon footprint? So that's the US landscape. Internationally, people fare much better. In fact, this Thursday or Friday, the EU, the European Council, is going to vote on an AI algorithmic bill, an AI audit bill is what it's called. So far ahead of us. China actually put out one on AI, about ethical principles of AI. So even they're ahead of us because they do AI just everywhere. So I'd say the US is pretty far behind. We're hyper-local and we don't have anything at the national level yet, not to mention standards, either international or on the US scale, about what makes a technical standard for AI.
And so, since there is a lack of regulation in the US, what would you like to see in the future? What would the ideal policy realm look like around AI in the US?
Yeah, ideally, I think the U.S., like Europe, needs a national data privacy legislation. I think that will solve many of the kind of niggling issues that come up where people aren't quite sure who has their data, who buys it, who sells it, where does it go. Data privacy legislation, and then I think technical standards for AI in a few realms. Medical uses need one that is very prescriptive. Right now, there's software to detect diseases and be used in the medical realm, even for things like your kidney or your different type things. There's no technical or policy guidance on that. A vehicle is another area, I think, is a second one, and then kind of medical research, where there's a lot of research being done. Clinical trials are done by AI. There's no regulation in those areas. So I think by those sectors, they need some specific guidance and then a national privacy. If we can do that in the U.S., that's a big ask, but that would solve some of the kind of issues in the back end, at least.
But should we remain excited about AI and what it can bring to us?
Totally, yeah. I mean, I'm excited about AI and things like art. So I run this big, it's called AI Village at this big hacker conference, and we had a whole day of AI art and music. And if you've played with it, if you're not familiar with it, there's something called DALL-E 2, which is a portmanteau of Salvador Dali and WALL-E 2 from the Pixar movie. And you put in text and it'll create some really fun pictures. And people are super creative. I think the AI art, the generative art is super exciting. I think the deep fakes are exciting with some caution, but people are, you're able now with one picture or a few pictures to recreate your dead relatives saying things. It's creepy, but there's people who get very emotional. They have, their dead, grandparent they've never met. That's super interesting. So the art, some of the music, some of the text type stuff with AI, with a caution, but being able to write things. So if you have a creative block and you're a writer and AI can help you kind of get over that writer's block, I think there's a lot to be excited about. I think medical diagnoses and not having to do 5-10 years of clinical trials, some of the big pharma companies are really working with each other, by the way, and with countries all around the world to be able to get drugs out faster and be able to do things to shorten the time period. Not to mention in science, which is my area, using AI for scientific discovery, just to do things faster. One example is there's these very large telescopes in South America coming up, and they detect transient, like once in a lifetime events. Using machine learning and AI, when they see that, they can then tip off another telescope in another area of the world to try to catch it before it leaves. You can only do that with machine learning very, very quickly. So yeah, I'm super excited about a lot of areas.
Yeah, and I've definitely tried out those tools where AI draws for you, and I encourage everybody to play around with them. But Sam, why don't we turn it to audience questions?
Yeah, the AI art is interesting. So there was a big, small controversy in the art world. Did you see this? There's a digital art competition, and someone submitted a digital piece of art that had been generated with AI, and there was a whole ethical debate about whether that was fair for the competition.
Right, and Christie sold, I think it was last year, 400,000 Christie sold at auction, this AI-generated artwork by these French students. And it was signed, it was signed with the name of the algorithm, like not the students. But $500,000,
Pretty good.
Yeah.
Great, so is there anyone in the audience who has any questions Yes.
You talked about a lot of the different fields. You know, one of the big ones in business process automation. Where do you see potential there, staying away from necessarily the personal privacy issues around personal data, but there are certainly a lot of other data points out there in, you know, predictive maintenance and, you know, process automation.
Totally, yeah. I come from a network security background, and a lot of the in the networks now they're looking at, you know, they call them self-driving networks, but being able to do more predictive, you know, when's it going to fail, even AI assistance, so that if something is failing, you know, even now, I was going to say the old days, but even now, your piece of equipment or IT thing fails, you've got to call a person, you've got to log in. There's more kind of sensing and predicting so that the AI can try to take care of it themselves before they call a person. I think a lot of the help desk functions can be automated. I see a lot of work in that area, both in networking, kind of help desk, things that, you know, take a person, they're tired and they're on call, and some of these things are very repeatable. And I think those are the things that AI is starting to do really well. Yeah.
Yes.
I've got a question around machine learning. Because if you're doing machine learning, you need to learn the right things. And what's the outcome of learning the wrong thing for artificial intelligence?
Right. Well, I mean, we've seen a lot of examples for that where, you know, not only does it learn, but the big thing people forget is with machine learning is oftentimes humans have to label that data. So when we collect a lot of data for, you know, the areas I deal with, people still have to label it. So we've seen where it's gone wrong, where you know, Google Pictures had labeled pictures. It was, I forget what the product was, pictures of gorillas or pictures of black people that were labeled gorillas because either the machine learning saw that black face as, you know, and what happened is there wasn't enough training data, and that's a big topic of discussion. Is what does it mean to have enough training data? Is it, and what they're finding is it's not necessarily a lot more data, but it is representative data. So different types of faces, different types of data, things that are anomalies, things that are ground truth. Before we're used to just using ground truth, but all those sorts of things to understand what is the, you know, what is the right amount to do learning from. Yeah, I don't know that there's an answer yet.
Because there's one specific Microsoft instance, I think, that was very problematic.
Microsoft Hey, which stood for thinking about you. Yes, that's a great example because because Meta did that again last month. They called it Blender, and it worked better, I guess. So Tay, if you're not familiar with it, this was launched in 2016, and it was supposed to be primarily a chatbot for younger people to kind of assist them thinking about you, to pick up on the lingo. Of course, what they did in real time is it trained itself on Reddit and Twitter, which, you know, you don't even have to use these things to know that.
And Twitter was not as bad yet.
And Twitter wasn't as bad yet, but to know that this is not the best training data. So within 24 hours, it was spewing out racist nonsense, because people learned that all Tay did was feed back what it learned, right? It wasn't making a judgment. It had no context. So what they're trying to do now is not just train on this corpus of words, but also try to give it context. And that's a hard thing because that's a human judgment, the context. I mean, even in our class at UChicago, there's students from all over. So students from different parts of the world had very different views on ethics and uses and context. So just trying to get a baseline, much of it I think is culture dependent too. But yeah, Meta had this one called Blender, and if you tried to feed it weird things, it would kind of stop you and say, I don't think we should be talking about that. So Dolly, you know, uses this GPT-3 for training, which is this general, this text thing. And I mean, the parameters it has are just in the billions. This thing took $14 million and a month to train, and it scooped up not just Reddit and Twitter, but books and, you know, the Internet Archive and all this kind of stuff to make a basis for learning. That's expensive, and that's become a problem. Not every company can spend $14 million to train AI.
So we have seen that the applications and programs are learning, are helping in decision making. I've visited in Barcelona, one of the supercomputational centers of Europa and Nostrum, talked to a senior scientist there who was also they participate in the building of the Microsoft supercomputer and working at CERN. explained what's going on. And then I asked him a question at the end, and I said, well, every 3 or 4 years you need a new generation of that supercomputer, and the supercomputer is involved in the creation of the new generation of supercomputers. Can you exclude that this computer in the creation of the next generation is developing a hidden agenda in his own interest? And he said, no, we can't exclude that. I then said, well, then you are kind of at Los Alamos, where science is kind of working in one direction, but it can be used in another one. Is there a danger in artificial intelligence that these applications and these models are developing their own hidden agenda?
Yeah, I mean, that's a controversial topic of can AI eventually be sentient or be conscious? And there was that famous, developer that stormed out because he thought AI was being sentient. I mean, sure there is, especially as you give it context, making value judgments and potentially, I mean, there was some work by a student done on can a robot social engineer you? Certainly it can. And then you're giving the robot kind of human-ish powers. I mean, certainly there's a danger to that as we give it more value judgments. If we say, as other countries are doing, which is to say there's a big move for emotion detection and social uses like that. And if the computer is in power to assign what emotion detection, what emotions mean, and then that's used to make other decisions about you, we're going to have this follow-on effect. We already see insurance companies making decisions based on, the color of your skin. You look a little jaundiced in that Instagram photo, and that was almost a decade ago. So as AI is making more of these decisions, as more data is cobbled together, yeah, I think there is a danger of that for the future.
How do you think new advances in like quantum computing or kind of higher computational speeds will impact AI's capability?
Yeah, I mean, one of the things that's, again, going back to the art stuff, or they call them large language models, these things, what has not been fair, I guess, is that industry has developed these. So they're super expensive. The computers are proprietary. They're Google computers. They're used by certain companies. They kind of have the keys to that AI. And that's not really fair from a research perspective. So as compute gets better, faster, cheaper, I'm at a supercomputing center at University of Illinois. As the compute gets refreshed, it gets cheaper, it gets faster. I see more kind of industry, government, nonprofit partnerships so that it's more accessible and that more people have access to the compute and the data. In the US, they have something called the National AI Research Resource, and they're trying to figure out how do you make these super expensive computers, because it's hard to get time on them, it's hard to get the data, it's hard to get people who know how to put it together to do something for you. That shouldn't be the exclusive realm of academics or industry. So how do you make this resource available to people who aren't just in those kind of niche privileged positions? So there's some thought process to it. It's not clear how that's going to pan out yet.
All right, well, yeah,
Okay.
one more.
I guess on the point of the criminal justice system, in terms of AI's applications, I was just wondering what would your opinion be, let's say we move from the criminal justice system, but using it more on a surveillance perspective, like for matters of national security and like preventative measures. Like, I guess my question is, with so many things going on lately, whether it's shootings or national tragedies, do you think it's useful to refine and use AI? I mean, they probably are using it now, but really bolstering it in that regards, like going through all those data points, like you said, Facebook has so much. Like, should we give access to governmental entities to do that to help prevent tragedies?
That's an interesting question because as you referred to, there's a fair amount of it done now. If you go through an airport, DHS, Homeland Security in the U.S. at least, has the face of over 75% of Americans, and they will use that to stop people. At the border, ICE has the same system, so they use that as well. I think there is a role. I think when you take it out of the context of tracking a person without some understanding of why, but I do think there is. They do this all the time. We work with some folks at University of Bristol. Bristol as a smart city in the UK, and they use AI a lot to look for things like a lot of people who, who are suicidal jump off the bridge, or they monitor the cities and streets for traffic flow. I think there's ways to use it, but your objective has to be clear. So for Bristol, it was reimagine the city, better traffic flow, better safety for people. I think doing it at that level, then you understand what you want to get out of it. If it's safety for schools, maybe you're looking for a kid who's got something that looks like a gun under his jacket or something like that. But I think the disconnect is not defining what you want to get out of the AI. But I for sure think there's a use, yeah.
Wonderful. Well, Anita, thank you so much for
Sure.
joining us tonight. It
Thank
was
you.
great to hear from you.
Thanks for your questions.